Alright, in this problem we have three graphs, and what we're trying to determine is which is the derivative of which, essentially. So it says down here, if y is equal to f, or y is g and y is h. So one of these is f, one is g, and one is h. Which is which so that the derivative of f is g and the derivative of g is h. Okay, so you kind of have to make a little guess and then go from there. Kind of guess and check a little bit and then adjust as needed. So let's see, to start with, I'm just going to make a guess that this red one, let's say, is F. Okay, let's just see what happens if that's true. So the derivative of F is actually 0 right here at the top, because you could tell the slope of the tangent line would be 0 or flat. So at this point, either the black or the blue function could be the derivative of F. Now here, the slopes of the tangent lines to F, if you sketch some in right through here, those slopes are negative from here to here, which means the derivative of F would be beneath the x-axis, which the black is not. So it's possible that this blue one is the derivative of F. And even down here still, the slopes of the tangent lines are negative to the red function, and then right here the slope of the tangent line becomes 0. So it looks to me like this blue function is the derivative of f because it equals 0 at the two places where the slope of the tangent line to the red function is horizontal. So I think what I'm saying is, that doesn't necessarily mean the red one is f, but what I'm saying is that the derivative of the red graph, we're going to write it like this, the derivative of the red is equal to the blue graph. Okay, now I'm going to erase these little markings here. Alright, now let's see the blue graph. Let's see if the black one is the derivative of the blue graph or if the red is the derivative of the black. That's the only other combination we have. So let's see, let's look at the blue graph here. The slope of the tangent line to the blue graph is negative, negative, negative. Now neither of the other functions are beneath the x-axis from here to here. So neither of the other functions could be the derivative of the blue graph. So that doesn't make sense. So let's go look at the black graph then. Okay, the black, let's see, if the derivative of the red is the blue, and I don't think that the derivative of blue is present, that probably means that the blue is the last one here, the H. That the red is, I'm going to assume, is G. Now let's go see if that's correct. Then the black function would be F, because the derivative of the black function would have to be the red function. So let's see if that works. The black function here is increasing, so its derivative excuse me, is positive. Right here, the black function has a horizontal tangent, so its derivative equals 0. So it makes sense that the red function might be the derivative of the black function because its derivative is, well, it is above the x-axis or positive here where the slopes of the tangent lines to the black function are positive. Then it equals 0 where the slope of the tangent to the black is 0, and same thing here. The slope of the tangent line to the black function is 0 where the red function equals 0. And then in between those two dots, the slopes of the tangent lines to the black function are negative, which corresponds to where the red is beneath the x-axis. So yeah, I think the derivative of the black function is equal to the red function. So it must be that the first function is, the black one is f. Point the lines the right way. So the black function is f. The derivative of the black function is the red. So the derivative of f is g. So the red must be g. And then the derivative of the red function is blue. So the derivative of g is h. So the blue must be h.